Questions 10, 11, and 12 in Chapter 7 are all asking you to balance some chemical equations. It's a classic problem type, and to really grasp it, we need to come to terms with two things. The first is numbers in chemistry. So let's show, here's an example of something that has numbers in different places, and depending on where the number is, it means a different thing. So you can have a number at the bottom right, at the top right, or in front. Those are the three places where you can have numbers in chemistry. At the top right is listed the charge. So this is the charge. It tells you how sticky an atom is. The bigger the charge, the more sticky it is. Because opposite charges attract, positive and negative charges will stick to each other. The number at the bottom right tells you how many atoms of an element are in a compound. So you get a compound when you put more than one atom together. And so you can sort of think of it as like a little truck. And the number at the bottom right is telling you how many of each type of Lego you used to make one of those trucks. So there would be 3 nitrogen atoms in this truck. And each nitrogen, and the whole thing would have a stickiness of -1. Okay, last but not least, there is a big number in front. That's called the coefficient, and that tells you how many trucks you have. So how many compounds you have. So in this example, it has a charge of -1. You have 3 nitrogen atoms in your little truck, and you have 4 trucks total. Now, when you balance equations, you only ever change the numbers in front. So we're not going to change the numbers at the bottom right. We're not going to change any numbers that may be at the top right. Only the numbers to the left in front of each element are the ones we can change. Okay, that's the first thing. The other concept here is that in chemistry, we're playing with our Lego set, our periodic that's represented by the periodic table, and all we're doing is taking Legos apart and putting them back together in different ways. We're not somehow creating Legos, and we're not destroying Legos. So however many Legos we start with, we have to have the same number when we stop. So each reaction is divided by an arrow. To the left of the arrow, that's what you start with, and to the right of the arrow is what you end up with. And we want to make sure that there's the same number of atoms of each element on both sides of that arrow. Okay, so I'm going to divide this here, so conceptually it's different. Now, there aren't too many tricks for this. We'll run into them maybe one at a time. As we run into them, I'll mention them. But really, you dive right in and look at how many of each element you have, one at a time. So on the left side, we have 2 nitrogen atoms. On the right side, we only have 1 nitrogen atom, because nothing is written in the bottom. So what do we need to multiply 1 by to give us 2? 2. 2 times 1 will give us 2. So now, every time you add a number, and notice you can only add numbers to the left in front of a whole compound. Every time you add a number, always start over, because by adding the number, you could have changed the balance of a whole bunch of things. So we have 2 nitrogens on the left, 2 nitrogens on the right, so that's balanced. How about oxygen? We have 2 oxygens on the left, and because we have 2 of this whole thing, you sort of distribute it. Because if you think about it, that 2 is like saying you have 2 NOs. So you have 2 N's and 2 O's. So you can distribute that 2 to each of the elements. 2 nitrogens and 2 oxygens. And it's that 2 oxygens on the right that make it balanced with the left. So we have 2 nitrogens on both sides, 2 oxygens on both sides. That is a balanced chemical equation. Okay, B. We're going to divide in our minds the left and right side of this equation, and we're going to work one element at a time. On the left side, we have 1 mercury. On the right side, we have 1 mercury. So mercury is balanced right now. On the left side, we have 1 oxygen. On the right side, we have 2 oxygens. So we need to multiply the left side by something. You always multiply the smaller side, the side that has a smaller amount, by something. So we have 1, we need it to be 2. What can I multiply 1 by to give me 2? 2. Now notice I couldn't put the 2 in the middle, and I couldn't put the 2 at the bottom. I have to put it to the left in front of the whole compound. All right, now we're not necessarily done. Every time you add a number, you want to go back and check to see that, make sure that everything is balanced. So 2 distributed gives us 2 mercuries on the left, but we only have 1 mercury on the right. So what can we multiply this 1 by to give us 2? 2. So we have 2 mercuries on the left, those are the Hgs, 2 mercuries on the right, so those are balanced. Distribute the 2, we have 2 oxygens on the left, 2 oxygens on the right, so the oxygens are balanced, everything is balanced, and so this equation is balanced. Okay, next one. We have 1 iron on the left. Nothing is written in the bottom right, so it's an implied 1. We have 2 irons on the right. So we're going to multiply something, we're going to multiply the iron on the left by something, because that's the one that has the less amount, 1 rather than 2. And what can I multiply 1 by to give me 2? 2. 1 times 2 is 2. Excuse me. So now the ions are balanced. Okay, let's go to the oxygens. We have 2 oxygens on the left. We have 3 oxygens on the right. Now, you can't multiply 2 by anything to give you 3, but what you can do is multiply both of these things by each other. So you can take the 3 on the right and put that in front here, and the 2 on the left and put it in front there. And by multiplying them by each other, you get the same amount. Notice now, you have 3, and you distribute it 3 times the 2 that's there. There's 6 oxygens on the left, 2, and distribute it 2 times the 3, that's 6 oxygens on the right, so the oxygens are balanced. But remember, anytime you add a number or change a number, you always have to go back and check to see whether everything else is balanced. So we have 2 irons on the left, 2, distribute it, 2 times 2 is 4 irons on the right, so the irons are not balanced. Let's go back to this iron and think about, we only have 1 there. What can we multiply that by to give us 4? 4. Okay, so let's go back, make sure everything's balanced. 4 irons on the left. 2 times 2, 4 irons on the right. So the irons are balanced. How about the oxygens? 3 times 2, that's 6 oxygens on the left. 2 times 3, that's 6 oxygens on the right. So the oxygens are balanced. So everything is balanced, and this overall is a balanced equation. So the unique thing that we saw there was if you can't multiply one number to get another, you multiply each thing by the other. So here we multiplied the 2 by 3 and the 3 by 2. And then we always go back and check to make sure that everything is balanced. All right, how about D? D, we have 1 sodium on the left, 1 sodium on the right. That's balanced. We have 2 chlorines on the left, only 1 on the right. So what can I multiply this 1 by to give me 2? 2. All right, every time you add a number, go back and make sure that everything is balanced. We have 1 sodium on the left, and you can see we have 2 sodiums on the right. So what can I multiply the sodium on the left by to give me 2? I can multiply that 1 by a 2. Okay, let's go back. How many sodiums do we have on the left? 2. How many sodiums do we have on the right? 2. How many chlorines do we have on the left? 2. How many chlorines do we have on the right? Distribute 2. So now everything is balanced, and this is a balanced chemical equation. Okay, 11, same idea. Divide the left and the right side. We want to make sure they have the same amount of elements of each element on both sides. So one at a time. We have 1 calcium on the left, 1 calcium on the right. So the calciums are balanced. We have 2 bromines on the left and 2 bromines on the right. So the bromines are balanced. So we didn't even have to add any numbers to this one. This one's already balanced. Okay, B. We have 4 phosphoruses on the left. We have 4 phosphoruses on the right. So that's balanced. We have 2 oxygens on the left. We have 10 on the right. So what can I multiply the lower number, 2, by to give me 10? 5. 5 times 2 will be 10. Every time you add a number, go back, make sure everything's balanced. 4 phosphoruses on the left, 4 phosphoruses on the right. 5 times 2, so 10 oxygens on the left, 10 oxygens on the right. All of the elements are balanced, all of the elements are balanced, so this overall equation is balanced. Okay, C. So first step is to separate in your mind the left and right sides. We want to make sure they're the same numbers of each element on those sides. We'll go one element at a time. We have 2 antimonies, that's SB, and 2 antimonies on the left. Only 1 antimony on the right. So what can we multiply the smaller number by to get the larger one? What can we multiply 1 by to give us 2? 2. Okay, so much for antimony. We have 3 sulfurs on the left and only 1 sulfur on the right. So what can I multiply? So 3 on the left, 1 on the right. What can I multiply the 1 by to give me 3? 3. 3 times 1 is 3. So the sulfurs are balanced. Now we should go back and make sure that everything's balanced every time we add a number. So we have 2 antimonies on the left, 2 antimonies on the right. So those are balanced. We have 3 sulfurs on the left, 3 sulfurs on the right, because these get distributed. So the sulfurs are balanced. Okay. How about the hydrogens? We have 1 hydrogen on the left. We have, remember to distribute, 3 times 2. That's 6 hydrogens on the right. So what can I multiply the smaller number, 1 by, to give me 6? 6. 6 times 1 is 6. Okay, so now let's go back. We have 2 antimonies on the left, 2 antimonies on the right, so those are balanced. 3 sulfurs on the left, 3 sulfurs on the right, because it gets distributed, so those are balanced. We have 6 hydrogens on the left, and then 3 times 2, 6 hydrogens on the right, so those are balanced. All right, last but not least, how many chlorines do we have on the left? Remember to distribute. We have 6 chlorines on the left. How many do we have on the right? Remember to distribute. 2 times 3 is 6 on the right. So every element here is balanced, so this whole equation is balanced. All right, how about D? One element at a time. So first, how many ions do we have on the left? 2. How about the right? Just 1. So we can put, what do we multiply the smaller number by to get the larger? 1. What can you multiply 1 by to give you 2? 2. Okay, next, oxygen. How many oxygens do we have on the left? 3. How many oxygens do we have on the right? Just 1. So what can I multiply the 1 by to give me 3? 3. All right, every time you add a number, go back and check. So we have 2 ions on the left, 2 ions on the right. So those are balanced. 3 oxygens on the left, 3 oxygens on the right. So those are balanced. How about carbon? We have 1 carbon on the left and 3 carbons on the right. So what can I multiply the lower number by to get the larger? 3. 3 times 1 will give you 3. So let's just go back, check one last time. 2 ions on the left, 2 ions on the right. Those are balanced. 3 oxygens on the left, 3 oxygens on the right. Those are balanced. 3 carbons on the left, 3 carbons on the right. Those are balanced. All of the elements are balanced, so this whole equation is balanced. All right, let's try 12. So we have 1 magnesium on the left, 1 magnesium on the right. So far, that's balanced. Oops. Okay, Ag is silver. We have 1 silver on the left, 1 silver on the right. So far that's balanced. Now, if you ever see more than 2 capital letters in something, then you know that you have what's called a polyatomic ion, if it's an ionic compound. So we have capital A, capital N, capital O. So if you ever have more than 2 capital letters, check to see if you cross the first one out, if everything after the first element repeats on the other side. You can see it does. So if that ever happens, if you have a polyatomic ion, a group of elements that repeat on both sides, then you can treat them as one thing, and that will simplify your work a little bit. So this whole thing is a polyatomic ion called nitrate. And the polyatomic ions, unfortunately, you would just have to memorize or look up in a table. But the sign, the flashing lights that tell you that you have one, is that we had a compound that had more than 2 capital letters in it. So we have 1 purple blob on the left side. Notice how I'm treating all of that NO3 as one thing. NO3 is just a purple blob. So we have 1 purple blob on the left side. You can see we have 2 purple blobs on the right side. So what do I need to multiply the 1 by to give me 2? 2. 1 times 2 is 2. All right, so let's go back, see how this has affected our balancing. We have 1 magnesium on the left, 1 magnesium on the right. We have 2 silvers on the left, only 1 silver on the right. So 2 on the left, 1 on the right. What can I multiply the lower number 1 by to give me the larger number 2? 2. 1 times 2 is 2. Okay, so 1 magnesium on the left, 1 on the right. Those are balanced. 2 silvers on the left, 2 silvers on the right. Those are balanced. 2 purple blobs, remember to distribute. 2 purple blobs on the left, 2 purple blobs on the right. So those are balanced. All of the elements are balanced here, so this whole equation is balanced. So the one new thing we saw there was having a polyatomic ion, a group of atoms that sticks together and acts like just one thing. And the sign that we had that was that we had a compound that had more than 2 capital letters, everything after the first element, so starting with the second capital letter on, would be the polyatomic ion. If you have that on both sides, you can treat that as just one blob. Okay, let's try B. 1 aluminum on the left, 2 aluminums on the right. So what can I multiply the lower number by to give me the 2? I can multiply it by 2. 1 times 2 is 2. Okay, how about copper? And actually, this is a good opportunity to talk about one other trick. So let's go back. We were doing it right, and we could have gone through that whole method, and we would have gotten the right answer. It would have been a little more work, though, and so I want to show you a shortcut. Notice that when we see this compound on the left, there's more than 2 capital letters. The capital C, capital S, capital O. When you have more than 2 capital letters, it's a sign that you might have a polyatomic ion. How do you know what the polyatomic ion would be? Start with the second capital letter, and then everything after it. That's what the polyatomic ion would be. If that repeats on the other side, SO4, and we see that it does, then it is a polyatomic ion, and you can treat it as one blob. We saw that in A for 12. Now, in addition to that, one other trick is, if something is ever by itself, like aluminum or copper, balance it last. Because when you put a number in front of it, it's not going to mess up anything else that you balanced. So that's another word to the wise tip. The only thing that's never by itself here is our blob, the SO4. So let's balance that first. We only have 1 purple blob on the left side. Notice the 4 in the SO4 is part of the blob itself. So that's not the number of blobs you have, that's part of the blob, or the polyatomic ion. So we only have 1 purple blob on the left, we have 3 on the right. So what can I multiply the lower number 1 by to give me the higher number 3? 3. 1 times 3 will be 3. So we've balanced those polyatomic ions. Now we can balance the copper. Where there's going to be 3 coppers on the left, there's only 1 on the right, so I can multiply the 1 by a 3 to make the coppers balanced. Last but not least, I can multiply the aluminums. I have 2 aluminums on the right, 1 on the left, so I can multiply the smaller number by 2 to give me the larger number on the other side. So let's go back and make sure everything's balanced. 2 aluminums on the left, 2 aluminums on the right. Those are balanced. 3 coppers on the left, 3 coppers on the right. Those are balanced. Remember to distribute 3 purple blobs on the left and 3 purple blobs on the right. So those are balanced. So everything's balanced, and this would be a balanced equation. So in addition to that polyatomic ion blob trick, we also saw in this one a word to the wise. If an element is ever all by itself, like aluminum and copper were here, balance those elements last, because the numbers in front won't mess up the other things you've balanced. All right, we go down to C, and we see yet again in this first one, we have 1, 2, 3 capital letters. That's a sign that we probably have a polyatomic ion. Look at everything starting with the second capital letter on. So that would be the polyatomic ion. So this would be the polyatomic ion. Does it reappear on the right side? It does. So we can treat that as just one thing. Nothing is by itself, so we're not going to leave anything last. We can just work from left to right. We have 1 lead on the left, 1 lead on the right. Remember, Pb is lead. It shares a root with the word plumbing, because lead used to be used by the Romans for their plumbing. It's a very soft metal that you can hammer into pipes very easily. So the leads are balanced. We have 2 purple blobs on the left, but only 1 on the right. So what do I need to multiply that 1 by to give me the 2? 2. 2 times 1 will give you 2. Okay, so lead should be balanced, the purple blobs should be balanced. How about sodium? We have 1 sodium on the left, 2 on the right, so I can multiply the 1 by 2 to make those balanced. And last but not least, we have, remember to distribute, 2 chlorines on the left, 2 chlorines on the right, so those are also balanced. Oops. So let's go back, make sure everything's good. We have 1 lead on the left, 1 lead on the right, so those are balanced. 2 nitrates, aka purple blobs, on the left, 2 nitrates on the right. Remember to distribute. So those are balanced. We have 2 sodiums on the left and 2 sodiums on the right, so those are balanced. And we have, remember to distribute, 2 chlorines on the left, 2 on the right, so those are balanced. So everything is balanced, and this whole thing would be a balanced equation. All right, last but not least, D. So we have 1 aluminum on the left, although here, notice, aluminum and hydrogen are both alone. So you might leave those last. You might leave those last. So first, because if we put numbers in front of this, it won't mess everything else up. So first let's balance the chlorines. I have 1 chlorine on the left, we have 3 chlorines on the right. So what do we need to multiply this 1 by to give us 3? 3. Okay, so now the chlorines should be balanced. And so we can start balancing the other elements. So on the left, we have 3 hydrogens. On the left we have 3 hydrogens. So on the left we have 3 hydrogens. On the right we have 2 hydrogens. And those 2 numbers don't go into each other. We saw this once before. When this happens, you multiply the 2 numbers by each other. So we'll multiply the 2 on the right by 3. And then we're going to multiply this 3 on the left by 2. Now, we already have a 3 there, so if we multiply it by 2, it'll be 6. Okay. So, that is where we are with that one. Okay, so we have the chlorines and the aluminums balanced. So last but not least, or the chlorines and the hydrogens balanced. So last but not least, the aluminums, we have 1 aluminum on the left, 1 on the right, so those are balanced. So let's go back, make sure everything's balanced. 1 aluminum on the left, 1 aluminum on the right, those are balanced. 6 hydrogens on the left, 6, remember to distribute, 6 hydrogens on the right. so those are balanced. We have 6 chlorines on the left, remember to distribute. And, actually when we change that, we only have 3 chlorines on the right, so to turn that 3 into a 6, you would just need to multiply it by 2. So, now, one more time, every time you add a number, you want to go back, make sure everything's balanced. 1 aluminum on the left, 2 aluminums on the right, so we need to multiply this left aluminum by 2. 2 aluminums on the left, 2 aluminums on the right, so those are balanced. 6 hydrogens on the left, 6 hydrogens on the right, so those are balanced. Remember to distribute 6 chlorines on the left, remember to distribute 6 chlorines on the right, so those are balanced. Everything is balanced, and so that is a balanced equation. So the one tricky thing there was to remember that if you have 2 numbers that don't go into each other, you multiply them each by each other. So in general, this is how you can balance equations. There are a few tips and tricks, like we noticed with the polyatomic ions, where you treat them like individual blobs, or balancing something by itself last. But in general, you just work from left to right and make sure there's the same number of things on both sides. The big number in front is the only number you can play with. Don't forget to distribute. That's a common error here. And the idea is that we have these Legos, we can take them apart and put them together in a different way, but we can't create and destroy them. So there have to be equal numbers of each type of Lego, of each element, on both sides of any equation.